to talk? Go to the back. All right, a photographer. Okay, we're going to get into some different symbolism now. A photographer would like to arrange 7 students in a row. In how many ways can he do this? Well, you know there's 1, 2, 3, 4, 5, 6, 7. There's 7 choices for the first one. Then we're down a person. Then we're down 2 people. Then 3 people. Then 4 people. Then 5 people. And whatever. Down 1, 2, 3, 4, 5. And then down to the last one, right? And the last one, there's only 1 person left to choose from. That is written, and you know that's written as 7 factorial, and that equals 5040. Now, what we're doing, there's a permutation button on your calculator. We're arranging 7 things out of 7 things. So can you just get used to that permutation button? I know I have to go 7 permutation 7 equals. Just type that into your calculator and you tell me what you get. Punch that in your calculator. I just want to make sure you're comfortable with that button, because you won't survive the next test without it. Everybody's good with the NP. Your button might look like this. My button looks like that. Are we good? If you're not good, you can let me know. A permutation of n distinct objects is an arrangement of all the objects in a definite order. So they're just telling you here order is important. It makes a difference if Bob sits here or John sits here, and if John sits, right? Because we're counting, it all makes a difference. For example, a choir has learned 8 songs for its spring concert. In how many different ways can the director arrange these songs to perform a concert program? Well, you could go 8 factorial, right? Because if you have 8 things to arrange, then it's 8, then you have 7, then 6, 5, 4, 3, 2, 1, and you get 4320. Now, if you have 8 P8, you're arranging 8 out of 8 things, then this is going to be, you can also use your permutation button and you will get the same thing. Is that my cell phone? Thank you. I'm going to turn it, is it off? Yeah, I'm going to turn it off. Okay, so let's look at this one. An investment club with 5 members wants to select a president and a vice president. And how many ways can this be done? Okay, well you could go like this, president, vice president, and you have 5 members, 5 choices for the first one, 4 choices for the next one, and that equals 20. Or you can do a 2 arrangement of 5 things, and you could punch that. Another way this is written is like this, P5 comma 2. These are just same symbols for it's different symbols for the same thing. But if you were to, hit the 5 key, then your permutation key, then the 2 key, and press equals, you would also get 20. Yes? Well, there's 5 members to choose from, and we're only picking 2 positions. So it's a 2 arrangement of 5 things. A permutation of n distinct objects taken r at a time, in this case 2 at a time, is an arrangement of r of the n objects in a definite order. So order makes a difference. It makes a difference if Bob is president and John is president, or vice president, or if John is president and Bob is vice president. It makes a difference. So this is denoted by PNR. N is the number of choices you have to work with. R is how many you are actually arranging, which can also be written like this as I mentioned before. So, a student club with 5 members wishes to select a president, a secretary, and a treasurer from its membership. No member can be selected for more than one office. How many ways can this be done? Well, you could have president, secretary, treasurer, 5 people to choose from for that spot, 4 people to choose from for that spot, and 3, so that equals 60. Or this is equivalent to a 3 arrangement of 5 individuals, and you would get exactly the same thing. Or if you prefer to write it like this, that's okay too. It's your personal preference. Huh? Oh, sorry. Yeah, you're right. My bad. My mistake. Oh, this one's out of... I don't seem to have any whiteout, but that's okay. I'll just write it P5, comma 3 equals 60. Oh, thank you. I knew I had someplace. Thank you very much. There are 8 swimmers in a race. Different prizes are awarded to the 4 swimmers who finish first. So that's first, second, third, and fourth, right? First place, second place, third place. If there are no ties in a race, then how many ways can this be done? Well, okay, you could go first, second, third, fourth. First, second, third, fourth, and you have 8 swimmers, 8 choices for the first one, 7 for the second, 6, 5, and that race is all happening at the same time, so it's fundamental counting principle, right? And that is equal to 168. Or you could do the 8P4. Oh, thank you. Yeah, 1,680. And I want to show you something. This so happens to 1680 is equal to 8 factorial over 8 minus 4 factorial. Okay, so what I'm trying to show you is we from the 8 factorial, we want to cancel out the 4 that were not chosen, right? So you have racer A, B, well, I won't do 8, 8, 7, 6, 5, 4, 3, 2, 1. Well, there were 4 that were not chosen, so we're subtracting 4 factorial. Or we're not subtracting it, we're dividing it out. So in effect, this is 8 times 7 times 6 times 5, right? So what we're doing is we're dividing out the people who were not selected, right? In that we're dividing out by the people that were not, so we're not interested in the order. So we're dividing out by the order of people not selected. Right? So there were 4 people not selected, so we're just trying to cancel out their order. There were 4 people not selected, so we're dividing out by 4 factorial. This is the formula for your permutation. This is the permutation formula. So this is going to be evaluate each expression. If we use the formula, it's 8 factorial over 8 minus 3 factorial, and that equals 8 factorial over 5 factorial, which is basically 8 times 7 times 6, and that is 336. I'm just showing you different ways of looking at it. Now, if we're arranging 6 things out of 6 things, we have 6 factorial. We're subtracting what we didn't select. Or in other words, we're dividing by what we didn't select. In this case, we're selecting everything. So 0 factorial is just 6 factorial divided by 1, and that equals 720. Remember, 0 factorial is defined as 1.
Is the reason why 0 factorial is defined to be 1 is it can be on the denominator and the denominator can be...
It saves a lot of calculations. Yeah, absolutely. Yeah. Otherwise, we wouldn't be able to use this in those cases where it's 0. Okay, suppose there are 723 books for sale in a major chain of bookstores. How many top bestseller lists are possible? Well, it's 723. Well, we have 723 books for choices to choose from for the first position, and then 722. So we can just go 723p10, and you will get approximately, now this is, even though I'm writing all the decimals from my calculator, it's still an approximate value because there's a lot of decimals that aren't there. Your calculator screen only shows so much. Can I answer any questions? A vice principal wishes to interview 5 students individually about their misbehavior. How many different orders are possible? Well, it's just he's interviewing all of them, so it's just 5p5. If you plug that in your calculator, that's what you get. If he's a sales representative, oh my. Oh, I'm, you know what, that answer is this answer. My bad. My eye jumped to the next answer. I agree with you. Thank you very much for pointing that out. I appreciate it. Unless you cut them up into pieces. Yeah, we won't do 20p20 out of 20 stores he's visiting 20. This answer is 2.43. Yeah, okay. Times 10 to the 18. Okay, now these arrangements or permutation questions can get more complicated. Find the number of the permutations. Permutations is another way to write arrangements. It's another word for arrangements. Okay, if the letter L remains in the middle position. Okay, so there's 7 letters, right? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. L is in the middle. There's only one way to do that. So that means we have 6 letters left to arrange. So we have 6 letters to choose from, then 5 letters to choose from, then 4 letters, then 3, 2, 1. This is in effect 6 factorial equals 720. There's no choice on the middle letter because they've stipulated that L has to be in the middle. Sorry? Sorry? I'm not sure. I didn't understand the question. Did did anyone? uh, Diploma is one possibility. Yeah. 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 The word diploma is counted in the 720. Okay. How many ways are there of arranging the word diploma so that the letters in O and I must always be together? So let's put OI together. And then we have to arrange D, P, L, M, O, A. Okay? So if these two have to be together, then we are in effect arranging 1, 2, 3, 4, 5, 6 objects, right? Because these two have to stick together. I'm sorry, I find your behavior really distracting. I can't focus. Stop, please. Okay, so if these two have to be together, there are 6 things to arrange, so it's 6 factorial, but it could also be I-O. So there's 2 factorial ways to arrange the 2 letters, and this is equal to 6 factorial is 120 times 2 is 240. Sorry? Okay. Again, I'm looking at the wrong answer, I think. Yeah, this is 1440. Okay, so this one is the same idea. How many permutations of the integers 1 to 6 are there if 5 and 6 have to be adjacent? So that's 1, 2, 3, 4, 5 things to arrange, right? And then this could be 5, 6, and 6, 5. There's 2 factorial ways to arrange that. So again, we're looking at 2 factorial for the 5 and 6, and then 5 factorial because now we're arranging 5 things, and that equals 240. Good? Can I explain anything better? At a used car lot, 6 cars are to be parked side by side. In how many ways can this be done if the one and only car with the sunroof must be at the right hand side? So 1, 2, 3, 4, 5, 6. The sunroof goes there, right? So that choice is gone. There's only one choice for that final position. That means there's 5, we're down a choice, so there's 5 left. So it's 5 factorial equals 120. Part B, the 3 black cars must be together. So assuming they're different black cars, 1, 2, 3, 4, 5, 6. I put too many spots. Let's say black 1, black 2, black 3. They're saying the 3 have to stick together, right? So you're arranging 1, 2, 3, 4 things. But how many ways are there to arrange 3 things? Yeah. And you get 144. Perfect. Ooh. This one's getting harder. Find the number of permutations of the integers 1 to 9, taken 5 at a time, at a time which contains 1. It has to contain 1. No repetition here, okay? So now, it has to include a 1, so watch. We have 1, 2, 3, 4, 5. The 1 could go there, right? 1, 2, 3, 4, 5. The 1 could go there. 1, 2, 3, 4, 5. The 1 could go there. 1, 2, 3, 4, 5. The 1 could go there. 1, 2, 3, 4, 5. The 1 could go there. One choice there, one choice there, one choice there, one choice there, one choice there. But there's 8 numbers left. So it could be 8, 7, 6, 5, 8, 7, 6, 5, 8, 7, 6, 5, 8, 7, 6, 5, 8, 7, 6, 5. So in other words, this is the same as, there's 5 cases, right? 5 cases where there could be a 1 in this number. So you could write it as 5 times 8p4. Another way of writing that. Out of the remaining 8, you're arranging 4 out of the remaining 8, and you should get 8,400. Good? No? Still have a question? Any questions on the material we covered today? Thank you.
Wait, why is this second digit on the line? There's no zero.
Yeah, it's just,
Only 9 digits.
yeah, we're not working with 0. 0 would complicate it. Do you want to try this one with 0? Okay.
How is 0 complicated?
Well, you can't start with the 0. So sometimes, if you start with the 1, then you have,
But this,
But it
for
doesn't matter.
this question itself,
Yeah, wouldn't it not matter? Because all you would do is you have 9 choices instead of 8.
well, be careful, you can't start with the 0. So let's do it. Let's see where we're working with this. So sorry. Sorry, I forgot to turn my phone off.
Oh, Jack. So the second one, for the first position, instead of having, is it 9 possibilities, it's 8.
Because it can't be 1, it can be 0. Unless the first position is 1.
Guys, can I ask you to work on this? I need to sign off.